The morning of February 20th, 1944, 700 miles east of London, deep inside the Third Reich, the workers at the Messerschmitt factory in Regensburg could hear them coming before they could see them. A sound like distant thunder, growing louder with each passing minute. Not the familiar drone of a few dozen aircraft, but something unprecedented, something that made the ground itself vibrate. Then they appeared through the winter clouds, wave after wave of four-engine bombers, their aluminum skin catching the pale sunlight. Boeing B-17 Flying Fortresses and consolidated B-24 Liberators, more than 1,000 heavy bombers in formations so vast they stretched from horizon to horizon. Around them swarmed 800 American fighter planes, Republic P-47 Thunderbolts and North American P-51 Mustangs, flying protective circles like wolves guarding a herd. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German fighter pilots, scrambling to defend their homeland, had never seen anything like this. The sheer number of aircraft filled them with dread. Where were all these planes coming from? How could the Americans build so many bombers, train so many crews, mount such massive attacks day after day? The answer to that question lay not in the skies over Germany, but 35 miles west of Detroit, Michigan, in the largest room in the history of mankind, the Willow Run bomber plant. A factory so immense that when it was completed in 1942, it contained more than 3.5 million square feet of manufacturing space under a single roof. The assembly lines stretched for a mile, making a dramatic 90-degree turn midway through to avoid encroaching on the adjacent airfield. At its peak, this single factory would produce one complete B-24 Liberator bomber every 63 minutes, 24 hours a day, 7 days a week, 8,685 bombers in total, nearly half of all the Liberators built during the entire war. And they were built by an army of workers that would have been unimaginable just a few years earlier. Women who had never held a rivet gun, African Americans given opportunities they had never had, teenagers too young to fight being trained through an apprentice school that processed 8,000 students per week, teaching unskilled young people, both male and female, to build one of the most modern combat aircraft of its day. People from all over America flooding into Michigan, many living in hastily constructed dormitories and trailer homes, working around the clock in a factory that became the beating heart of American industrial might. The German High Command had known about American industrial capacity in theory. They understood that the United States could produce vast quantities of materiel. What they failed to grasp until it was too late was what that meant in practice, what it meant when a single factory could produce more bombers in a month than some nations could build in a year. What it meant when production methods perfected on automobile assembly lines were applied to combat aircraft. What it meant when the full weight of American industry turned toward a single purpose, the destruction of the Third Reich. This is the story of how that factory came to be, how it nearly failed, how it succeeded beyond anyone's expectations, and how the bombers it built, flown by young men barely older than the workers who assembled them, helped break the back of the Luftwaffe and make the invasion of Europe possible. The story begins not with engineers or generals, but with a single night in a hotel room in San Diego, California, in early 1941. Charles Emil Sorensen was 6 years old, a Danish immigrant who had risen to become the production mastermind behind Ford Motor Company's legendary assembly line. He was hard, demanding, and utterly confident in his ability to solve manufacturing problems that seemed impossible to everyone else. In 1913, he had helped Henry Ford perfect the moving assembly line that made the Model T affordable to millions. In the decades since, he had overseen the production of more than 30 million automobiles. On this particular night in February 1941, Sorensen found himself staring at a problem that had nothing to do with cars. He had just toured the Consolidated Aircraft Factory in San Diego, where the B-24 Liberator bomber was being hand-built using methods that seemed to him hopelessly outdated. Aircraft were assembled outdoors in the California sun. Major components were custom-fit to each individual plane, meaning no two Liberators were quite alike. There were no accurate blueprints, no standardized measurements, no assembly line discipline. Consolidated Aircraft had been asked by the United States Army Air Corps to expand production dramatically. The company was struggling to build one bomber per day. The Army needed hundreds, then thousands. The war, raging across Europe and Asia, demanded more aircraft than anyone had thought possible. The government had approached Ford Motor Company about helping. Perhaps Ford could build subassemblies, wing sections, or fuselage components that Consolidated could then assemble into complete aircraft. Ford, President Edsel Ford and Sorensen had traveled to San Diego to see exactly what they were being asked to build. What Sorensen saw reminded him, as he later wrote in his memoirs, of the way Ford had built cars 35 years earlier. It was craft production, not mass production. Each aircraft was essentially unique, built by skilled workers using hand tools and eyeball measurements. It was fine craftsmanship, but it was impossibly slow. Reuben Fleet, president of Consolidated Aircraft, was polite but skeptical when Sorensen expressed his concerns. Fleet had been building aircraft for generations. He understood airplanes. What could an automobile man possibly teach him about building flying machines? When Fleet asked how Ford would approach the problem, Sorensen responded with characteristic confidence. "I will have something for you tomorrow morning." He was not kidding. Sorensen sequestered him in his room at the Coronado Hotel that night with nothing but a stack of hotel placemats and a pencil. He worked through the night, breaking down the B-24 into its component assemblies and sub-assemblies, designing a production flow that would move continuously through specialized workstations, exactly the way automobiles move down an assembly line. By 4 in the morning, he had sketched out the entire process on the backs of hotel placemats: center wing, outer wings, fuselage sections, tail assemblies, nacelles, all built in separate cells and then brought together on a final assembly line by overhead cranes, sequential assembly, standardized, interchangeable parts, continuous flow. The fundamental principles of mass production that had revolutionized the automobile industry applied to the largest and most complex aircraft then in production. At breakfast the next morning, Sorensen presented his plan to Edsel Ford, who enthusiastically endorsed it on the spot. They then showed it to Fleet and George Meade, the government's procurement director for the Advisory Council for National Defense. Fleet's counteroffer was telling. Perhaps Ford could build 1,000 sets of wings. Sorensen's response was blunt: "We will build the whole plane or nothing." It was an audacious claim. Ford had built aircraft before. The Ford Trimotor had been a successful passenger plane in the 1920s, but the company had largely abandoned aviation in the years since. Now Sorensen was proposing that Ford would not just build bombers, but build them on an assembly line faster than anyone thought possible. He promised the government one complete B-24 bomber every hour. The response from the aviation industry ranged from skepticism to outright mockery. Dutch Kindleberger, president of North American Aviation, spoke for many when he said, "You cannot expect a blacksmith to make a watch overnight." The automobile manufacturers, he implied, were too crude, too unsophisticated to build something as complex and precise as a modern combat aircraft. Aircraft required tolerances measured in thousandths of an inch. They required materials and manufacturing techniques completely different from anything used in automobile production. Most importantly, aircraft were complex, constantly evolving designs. Army requirements changed week by week as combat experience revealed new threats and new solutions. How could a mass production system, which depended on fixed, standardized designs, possibly accommodate that kind of constant change? These were legitimate concerns, and in the months and years that followed, Willow Run would prove every one of them justified. The transition from automobile production to aircraft production would be far more difficult, far more expensive, and far more frustrating than anyone at Ford anticipated. But Sorensen had made his promise, and Henry Ford, old, increasingly erratic, but still possessing the stubborn determination that had built one of the world's great industrial empires, backed him completely. The site Ford selected for his bomber plant was farmland he owned near a small creek called Willow Run, 35 miles west of Detroit. The land was flat, empty, and perfectly situated between Detroit and Ann Arbor, with rail lines and roads already in place. Construction began in March 1941. The architect was Albert Kahn, the same man who had designed Ford's massive River Rouge complex. Kahn called Willow Run the most enormous room in the history of man, and he was not exaggerating. The main building alone would contain 3.5 million square feet of manufacturing space. The assembly line would be over a mile long. Adjacent to the factory, Ford would build a 1,484-acre airport with 6 runways and 3 aircraft hangars, the largest of which could house 20 B-24s simultaneously. The sheer scale of the project was staggering. 7 million square feet of total floor space, construction materials that would have built a city, a workforce that would eventually peak at more than 42,000 people, all needing to be transported to a site that had no highway connections, no streetcar lines, no existing infrastructure of any kind. The federal government would eventually build the nation's second freeway, what is now Interstate 94, specifically to move workers and materials to Willow Run. They would spend $20 million to construct an entire community adjacent to the plant, Willow Village, complete with dormitories for single workers, small houses for families, trailer homes, schools, police and fire stations, commercial buildings, an instant town that would house more than 15,000 people. But even as construction crews worked around the clock to build the factory, Ford engineers faced a more fundamental problem. They did not actually know how to build a B-24. Consolidated Aircraft guarded its designs jealously. The company had no real blueprints to share, only rough sketches and templates. Major components were hand-fitted to each aircraft. Measurements were approximate. The entire production process depended on skilled craftsmen who knew through experience how parts should fit together. For 6 months, Sorensen shuttled teams of 70 engineers and draftsmen back and forth on the 2,300-mile journey from Ford headquarters to Consolidated's San Diego plant. They had to learn every detail of B-24 construction, then translate that knowledge into proper engineering, drawings, precise measurements, and standardized manufacturing processes. Tool and die maker Martin Chapin was among the first wave of 240 Ford personnel sent to San Diego. What he saw shocked him. Consolidated had built and assembled aircraft for generations, and they thought our innovations were almost sacrilegious, he later recalled too. They built airplanes with plumb bobs and levels, while we were used to sophisticated fixtures and gauges. One example captured the culture clash perfectly. The landing gear pivot on the B-24 was assembled from half a dozen pieces of steel, a couple of large tubes, and some flat plates, all held together by nearly 100 welds. Each weld had to be X-rayed to ensure structural integrity. The entire process was slow, expensive, and prone to variability. Ford engineers looked at this component and concluded what would become their mantra for the entire project. Consolidated had never engineered the B-24 for high-volume production. The B-24 Liberator was, in many ways, a remarkable aircraft. It had been designed in 1939 by Consolidated Aircraft as a successor to the Boeing B-17 Flying Fortress. Where the B-17 was rugged and forgiving, built around a thick, strong wing that could absorb tremendous battle damage, the B-24 was built for range and payload. Its secret weapon was the Davis wing, a revolutionary design created by freelance aeronautical engineer David R. Davis. Unlike conventional wings, which were designed to generate lift through their shape, the Davis wing was designed in reverse. Davis started with a low-drag, a teardrop shape, and then modified it to provide lift. The result was a wing with a high aspect ratio, long and thin, but deep enough to be structurally sound. When Consolidated first tested the Davis wing, in a wind tunnel at the California Institute of Technology. The results were so good that the engineers were skeptical. They recalibrated the wind tunnel and ran the tests again. Then a third time. The numbers held. The Davis wing produced significantly less drag than conventional designs, while still generating enough lift to carry a heavy bomb load. It was an engineering marvel. The wing gave the B-24 a cruise speed of over 300 miles per hour, faster than the B-17. It gave it a range of more than 3,000 miles, allowing missions deep into enemy territory. It allowed the aircraft to carry 8,000 pounds of bombs in each of its 2 bomb bays, twice the capacity of early B-17 models. But the Davis wing came with a price. The high aspect ratio meant higher wing loading, 35% higher than the B-17. The wing was thinner, lighter, more efficient. It was also more fragile. Where the thick wing of a B-17 could absorb hits from anti-aircraft fire and keep flying, often bringing crews home, even with massive damage, the Davis wing was vulnerable. Direct hit could cause catastrophic structural failure. Wings would snap off completely if critically damaged. Fuel tanks positioned in the wings and upper fuselage made the aircraft particularly prone to fire. Crews who flew both types had strong opinions. Many preferred the B-17 precisely because it seemed more survivable. The B-24 might be faster and carry more bombs, but when flak started bursting around you at 25,000 feet, ruggedness mattered more than speed. General Henry Arnold, commanding the Army Air Forces, reportedly told consultant Charles Lindbergh that combat squadrons greatly preferred the B-17 because when we send the 17s out, they come back. When we send the 24s out, most of them don't, but the military leadership favored the B-24 for exactly the reasons crews sometimes feared it. It could fly farther, carry more, and be produced in greater numbers. In the Pacific Theater, where targets were separated by vast expanses of ocean, the B-24's range made it indispensable. In Europe, where the strategic bombing campaign demanded maximum tonnage of bombs dropped on German industry, the B-24's payload capacity was crucial. And so, the orders kept coming. Thousands of bombers, more than anyone had ever built before, which brought Ford and Willow Run face to face with the fundamental challenge that would define the factory's first 2 years of operation. The B-24 was not designed to be mass-produced. Every aspect of its construction reflected the hand-built craft tradition of the aviation industry. And Ford was trying to build it the way they built cars. The Willow Run plant was formally dedicated on October the 22nd, 1941, in a ceremony attended by the Major Jimmy Doolittle of the United States Army Air Forces. Less than 2 months later, on December the 7th, Japanese aircraft attacked Pearl Harbor, and America was at war. Production had already begun in summer 1941, but the factory was far from ready. Parts of the building were still under construction, even as workers in completed sections tried to begin assembly. Plywood partitions sealed off finished areas from construction zones. The chaos was extraordinary. And then the problems began to multiply. The first issue was fundamental. Ford engineers, accustomed to working with steel, had designed tools and dies for automobile production. They ordered similar steel dies for shaping the aluminum components of the B-24. But aluminum, which comprised 85% of the bomber's structure, was softer than steel. The hard steel dies damaged and defaced the aluminum, leaving marks and distortions that made parts unusable. Dies and machine tools had to be thrown out and redesigned. Millions of dollars wasted, precious months lost. The second issue was even more challenging. The Army Air Forces kept changing the B-24's design. Combat experience in Europe revealed new threats. New defensive gun positions were added, new radar equipment, new bombing systems. Each change required modifications to the assembly line, new tooling, new training for workers. Ford's mass production system depended on standardization. The military's constant design changes made standardization impossible. The third issue was the workforce. Willow Run was 35 miles from Detroit, At a site with no existing transportation infrastructure, workers had to commute by bus, 35 daily trips on public lines, plus 130 more on private carriers. By early 1942, there were no rental rooms available within a 15-mile radius of the plant. Resourceful landlords collected double or triple rent, renting rooms in shifts. One tenant slept while another worked. Housing construction could not keep pace with hiring. Workers lived in cars, in makeshift shelters, anywhere they could find. The federal government finally stepped in, building Willow Village almost overnight, dormitories for single workers, small houses for families, 1,000 trailer homes added in a matter of days. By the end of 1943, Willow Village housed more than 15,000 people, a complete community that had not existed 3 years earlier. But housing was only part of the labor challenge. As young men were drafted or volunteered for military service, Ford faced an acute shortage of skilled workers. The company began hiring women in unprecedented numbers. By May 1942, 15% of the Willow Run workforce was female. That number would eventually rise to 35%. More than 12,000 women working jobs that had been considered male work just months earlier: riveting, welding, operating massive machine tools, assembling complex mechanical and electrical systems. Women did all of it, and they were paid the same 85 cents an hour that men earned for the same work. Roswell Monroe, who came to Willow Run from Kentucky, would later be claimed by Ford as the inspiration for the iconic Rosie the Riveter poster, though other sources dispute this. What is not disputed is that thousands of women stepped into roles that transformed American labor forever. African Americans, too, found opportunities at Willow Run that had been largely closed to them in civilian industry. The massive labor shortage and federal government pressure forced Ford to hire without the racial discrimination that had characterized much of American industry. The result was a workforce that became a model of wartime diversity. Out of sheer necessity, Willow Run assembled 42,000 people from different backgrounds, different experiences, different places, and asked them to build the most complex machine then in mass production. And to train this diverse workforce, Ford created the Aircraft Apprentice School, processing up to 8,000 students per week through training programs that taught unskilled workers, young and old, male and female, how to build a B-24 Liberator. The school used full-sized plywood mock-ups of the bomber's structure so that students could learn the location and function of every component. They practiced on real tools, real materials, real assemblies. A 16-year-old who had never held a rivet gun could complete training and report for work on the assembly line, where they would help build aircraft that would fly missions over Germany just weeks later. These young workers, some barely out of high school, became part of the factory's folklore. Ford even hired 8 people of short stature to climb inside the B-24's wings to hold backing plates during riveting operations, a job that required someone small enough to fit in the confined spaces where the outer wings attached to the center wing section. According to accounts from the time, these workers were very proud of what they were doing. For the first time in their lives, they were not sideshows. They had real jobs, contributing to the war effort in ways that mattered. But skilled or unskilled, young or old, the workers at Willow Run in 1942 were not building many bombers. By the end of 1942, Willow Run had produced only 56 B-24 bombers in total. Most of those had been assembled partially by Consolidated or Douglas aircraft in Texas and Oklahoma, using components shipped from Michigan. The first truly Willow Run-built B-24, christened the Spirit of Ypsilanti, had rolled off the line in September. But the production rate remained glacially slow. The factory that was supposed to be producing 1 bomber per hour was barely managing 1 bomber per week. Critics began calling it "Will It Run?" Senator Harry S. Truman, who headed a presidential committee charged with eliminating wartime production waste, visited the plant twice, in April 1942 and again in February 1943. He was not impressed. A 1943 congressional committee authorized to examine problems at the plant issued a highly critical report. Ford Motor Company had created a production line that too closely resembled an automobile assembly line, despite the warning of many experienced aircraft men. The quality of the early B-24s was uneven at best. Some were deemed unfit for combat and assigned to training bases, reconnaissance patrols, and transport duties. The Army Air Forces needed combat-ready bombers, and Willow Run was not delivering them fast enough. Sorensen blamed delays on doing business with the government, treading through a maze of conflicting priorities and regulations, rancorous labor relations and wildcat strikes, housing shortages, and erratic delivery of essential materials. All of this was true, but he did not mention the hard steel dies, the constant design changes, the fundamental challenge of applying automobile production techniques to aircraft construction. The plant was failing, or at least it was failing to meet the impossible expectations that Sorensen himself had created with his promise of one bomber per hour. And then, in 1943, something began to change. Ford and Consolidated Aircraft reached an accommodation during the first quarter of 1943. Willow Run stepped up outsourcing of parts production and subassemblies to almost 1,000 Ford factories and independent suppliers scattered across the country. The main plant would focus on what it did best, final assembly using the standardized components. Completed planes would fly off to field modification centers where military technicians could make fixes, upgrades, and customizations without shutting down the production line. The change in strategy was transformative. Production numbers began climbing steadily. 31 airplanes in January 1943, 190 by June. The engineers were learning. The workers were gaining experience. The bugs in the system were being identified and eliminated one by one. Perhaps the most impressive breakthrough came in the assembly of the B-24's center wing section, the massive structural component where the fuselage joined the wings and all four engines mounted. Consolidated had built each wing using temporary jigs that held the structure in place during assembly. Each wing required custom fitting, handwork by skilled craftsmen. The process consumed 250 man-hours per wing. Ford engineers developed a permanent jig into which wing assemblies could be moved in and out by overhead crane. Parts were prefabricated to exact specifications. Riveters knocked the wing components together. Then the entire center wing assembly was sent to a multiple function machine that completed 42 precision machining operations to 2/10,000ths of an inch accuracy in 17 minutes. The time required dropped from 250 hours to 1 hour. 1 hour for the most complex structural component of the aircraft. It was mass production at its finest, the culmination of everything Ford had learned building automobiles applied to the greatest industrial challenge of the age. By March 1944, just weeks after Charles Sorensen was forced out of Ford in an internal power struggle, Willow Run achieved his dream. 453 airplanes in 468 working hours, one complete bomber every 63 minutes, exactly as he had promised 3 years earlier. The delivered price of a B-24 dropped from $238,000 in 1942 to $137,000 in 1944. Ford's efficient assembly line methods had cut the cost nearly in half while dramatically increasing quality and production speed. Willow Run's monthly output nearly equaled the entire airplane production of Japan that year. A single factory in Michigan was outproducing an entire industrialized nation, and the bombers rolling out of Willow Run were joining thousands more B-24s built by Consolidated plants in San Diego and Fort Worth, by Douglas Aircraft in Tulsa, and by North American Aviation in Dallas. Together, these factories would produce more than 18,000 B-24 Liberators by the war's end, making it the most produced heavy bomber in history. But production numbers alone do not win wars. What mattered was what those bombers could do when they reached the skies over Europe. Throughout 1943, the strategic bombing campaign against Germany had been a bloody, grinding struggle. American bombers flying daylight precision raids suffered horrific casualties. On August 17, 1943, The mission to bomb ball-bearing factories at Schweinfurt and aircraft plants at Regensburg resulted in the loss of 60 B-17s, with another 155 badly damaged. 552 American airmen were listed as missing. A second attempt on Schweinfurt on October 14, 1943, became known as Black Thursday. Of 291 attacking fortresses, 77 were lost and around 122 damaged. The loss rate exceeded 20%, unsustainable by any measure. The problem was simple. German fighter defenses were overwhelmingly effective against unescorted bomber formations. The B-17s and B-24s flew in tight, defensive boxes, their combined machine gun fire designed to drive off attacking fighters. But against determined attacks by Messerschmitt Bf-109s and Focke-Wulf Fdu-190s, the bombers were slaughtered. The 8th Air Force suspended deep penetration raids into Germany, without long-range fighter escorts that could accompany the bombers all the way to their targets and back. The losses were simply too great. Then, in early 1944, everything changed. The North American P-51 Mustang arrived in England in significant numbers. With drop tanks, the Mustang could escort bombers all the way to Berlin and back, a range that no previous fighter could match. Just as importantly, Major General James Doolittle, who took command of the 8th Air Force in January 1944, changed the fundamental tactics of the escort fighters. Previously, fighters had been required to stay close to the bomber formations, flying defensive circles. Doolittle gave a new order: destroy the enemy air force wherever you find them, in the air, on the ground, and in the factories. The fighters were unleashed. Instead of waiting for German fighters to attack, American P-51s and P-47s hunted them aggressively, pursuing them back to their airfields, strafing them on the ground, forcing the Luftwaffe into battles it could not win. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The strategy came to fruition in late February 1944 during Operation Argument, known to history as Big Week. For 6 consecutive days, from February 20th to February 25th, the 8th Air Force and the 15th Air Force, based in Italy, launched the largest coordinated bombing offensive of the war to date. The targets were German aircraft factories, the industrial heart of the Luftwaffe's production system, Messerschmitt plants at Regensburg and Augsburg, Focke-Wulf factories at Bremen and Oschersleben, assembly plants, engine manufacturers, component suppliers across the Reich. More than 1,000 heavy bombers attacked on the first day alone. Wave after wave of B-17s and B-24s, many of them fresh from Willow Run and other American factories, their silver wings reflecting winter sunlight as they droned eastward toward Germany. Around them flew 800 escort fighters, the new long-range Mustangs and the rugged Thunderbolts, eager for combat. The Luftwaffe had no choice but to respond. Every available fighter was scrambled to defend the factories. And in the skies over Germany, the German fighter force was systematically destroyed. On the first day of Big Week, 127 German fighters were shot down for the loss of a single P-51 Mustang. The exchange rate was catastrophic for Germany. In February 1944 alone, 434 German fighter pilots were killed, 17% of the entire force. Many were experienced veterans, irreplaceable men who had fought since the beginning of the war. The Americans lost bombers too. Over 600 American aircrews became casualties during Big Week. But for every American bomber that went down, German factories were being reduced to rubble and German fighter pilots were being killed in numbers they could not replace. The Luftwaffe tried desperately to increase production. Despite the bombing, German single-engine fighter production actually increased dramatically through 1944. Monthly production reached its wartime peak in September 1944 at 3,031 fighter aircraft. But production meant nothing without pilots to fly them and fuel to power them. The experienced pilots were dead. The fuel supplies were being destroyed by Allied attacks on synthetic oil plants. And the new pilots, hastily trained teenagers, rushed into combat with minimal preparation, were being shot down almost as fast as they could be produced. By the time of the Normandy invasion, On June the 6th, 1944, the Luftwaffe had only 80 operational aircraft on the North French coast. They managed about 250 combat sorties against 13,743 Allied sorties that day. The German Air Force had been broken as an effective fighting force. This was the real victory of mass production. Not just that Willow Run could build a bomber every 63 minutes, but that those bombers, combined with thousands more from other factories, could overwhelm German defenses through sheer numbers. The Luftwaffe could not shoot down 1,000 bombers when 1,000 more would arrive the next day. They could not win a war of attrition against an industrial system that could replace losses faster than they could inflict them. The young workers at Willow Run, the women riveters and the teenage apprentices, the African-American machinists and the Kentucky farm girls learning to weld, they were all part of this victory. Every bomber they built was another hammer blow against the Third Reich. Every hour they shaved off production time meant more aircraft in the sky sooner. The accumulated weight of their labor, multiplied across thousands of workers and hundreds of days, became an unstoppable force. By September 1944, Willow Run employees celebrated the completion of their 6,000th airplane. Ford planned to increase production to 650 planes per month, one every 45 minutes. But that milestone would never be reached. The government drastically cut its order for B-24s. The war's focus was shifting from Europe to Japan, where the more advanced B-29 Superfortress was needed. The B-29s would be built elsewhere. Willow Run's production began winding down. The last B-24 rolled off the assembly line on June 28, 1945. 8,685 bombers in total, plus another 1,893 knockdown kits shipped to other plants for final assembly. The factory that had struggled so mightily in its first year, that had been mocked as Will It Run, had ultimately produced more heavy bombers than any other single facility in history. It had employed more than 42,000 people at its peak. It had trained thousands of young workers through its apprentice school. It had proven that mass production techniques could be applied to the most complex machines humanity had yet created. After the war, Ford chose not to exercise its option to purchase Willow Run from the government. The factory changed hands, first to Kaiser Frazer for automobile production, then to General Motors for transmission manufacturing. Most of the vast complex was eventually demolished. Today, part of the site serves as the American Center for Mobility. A few buildings remain as the Yankee Air Museum, preserving the memory of the factory that helped win World War II. The hyperbolic claims, sometimes made about Willow Run, that a single teenage welder tripled wing strength or that one innovation broke Germany's fighter screen, are not quite accurate. The truth is both more complex and more impressive. There was no single hero, no one miraculous breakthrough. Instead, there were thousands of small innovations, accumulated improvements in efficiency and quality, the collective effort of tens of thousands of workers learning to do something that had never been done before. The real breakthrough was not technical, but industrial. It was the realization that complexity could be conquered through standardization, that craft production could be transformed into mass production, that the same principles that made automobiles affordable to millions could be applied to the most advanced weapons of war. And the real heroes were not individual geniuses, but ordinary people, many of them very young, who learned new skills under pressure, who worked long hours in difficult conditions, who built bombers that would carry the war to the enemy and help secure victory. The B-24 Liberator was never as beloved as the B-17 Flying Fortress. Its crews often preferred the ruggedness of the older design. But the Liberator flew farther, carried more, and was produced in greater numbers than any heavy bomber in history. And when American industrial might reached its peak in early 1944, when 1,000 bombers could darken the skies over Germany day after day, when the Luftwaffe broke under the accumulated weight of attacks, it could not stop. The Liberators were there, many of them fresh from Willow Run, flown by crews barely older than the workers who built them. That is the real story. Not one teenage welder, but thousands of workers. Not triple strength, but relentless production. not breaking Germany's fighter screen in a single stroke, but grinding it down through accumulated pressure that could not be sustained. American industrial capacity, applied with focus and determination, became a weapon more powerful than any single technology. And Willow Run, the largest room in the history of mankind, was the beating heart of that effort. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.